Now let's take a look at the product itself. Stream is a product for sequence analysis. It's been used for financial analysis and extensively used for financial management and understanding the data. But it's not just limited to financial data sets. It can be used for any place there is a sequence data is available, or in a more traditional way, people talk about it as time series data. And again, some of those things can be used. Let me show you how one can use or may have more creative ways of using it. So here is a sequence stream website, and people. This is works online, and any number of people can log in, and they exchange what they do as well. One if one person leaves it in some place, the other person can pick it up, and then so first thing first, that what you do is, here is where you have different applications from this stream. Here we have um, uh, sequence analysis and dashboard applications, and then here's a sign in, and it talks about few related things about documentation and such. So first thing you is, if you want to try it out, you go log in. If you don't have a login, create a login and come back here, and then yeah, log in yourself, and then you get to first site here, and it shows you on the left side all the data sets that you have created so far. And then you can see all the different data sets you have. You can create new data sets. You can add data to the data sets. There are some rule of thumb how and what a data set is. Data set is a collection of data, similar data, I would say. So if you have a data from let's say that you're tracking all the technology stocks, then you may want to create a technology stock as a data set and capture all the data from that technology sector into here. And again, the same data can go into others, and without having to duplicate the same data as well, right? So creating a data set is quite easy. You just click and then type in the name of the data set, like test one. It should be unique across, so I'm going to call it as test 2, for example, and then you add data set, right? So test 2 is ready here, and then you can use that, you can add data. So like data can be in any of the formats. It can be in a Parquet file, CSV, Excel spreadsheets, TXT files, or it's about 10 different formats of the data that you can use, or it can come from a database. I think it is tested for more than 25 different databases: Postgres, Elasticsearch, InfluxDB, or Oracle, SQL, or whatever, whatsoever, or MySQL, and different kinds of database. Or it can be a local path, like if you have a local file that you can also on this server. The difference between file upload is you have a file locally. This is file on this server where you have installed this application, and it just creates a link to the path when the file changes. This also reflects it, so you can manage and explore the real data sets. Or it can come from a URL. You can say HTTP, here is a place where you can get the data, and then it can do that too. uh, and then for financial application, what we do is the data gets created every day when the stock market closes, or when the new data is visualized. So that data resides in any of these forms, and this application automatically goes and pulls it. So it's a way of how you automate it. It can pull every minute, every 10 minutes, every so often, just like a cron job in Unix. Okay. Um, so that's about it. Next thing is, let me give you an example of what your experience could be. Suppose if I have a data, for example, a CSV data, right? Usually, if you let me open this. If you double click it, it will take some time for it to open, and um, yeah, it opened here. Um, and still take some time for Excel spreadsheet. As you can see, it takes about 10 to 15 seconds for it to data, and this is the data, right? Um, but now, as you can see, this is time series data or a sequence data collected over. This is the time component. Exactly, don't know what the time component is. And these are all the different metrics, numbers that got collected. This is what you will see from a regular application. Now, if you want to explore this data, you need to write code to perhaps see, view the chart or something. Here, chart. Anyways, I don't know exactly how that's done. There is an easy way of doing charting and everything for this. Um, in addition to that, you exactly don't know what this particular means, right? This name of this. So these are all the challenges by using a generic tool. Let me allow you what you might feel or experience when you use tool such as Stream. So we have looked into what do people do when they do data analysis, right? So I want to be able to take this data and drop it directly here, right? Um, so if I go to upload and then go drop the data, uh, within few seconds you should be able to see the data just like that, and you should be able to search for this data or even filter this data. For example, maybe you want to see everything that has 6 in them or 3 6 in them. So everywhere the data table provides a unique way of filtering the data, sorting the information. Also in the first column you can see what is the time. It automatically converts the time into native format and shows you what is that data looks like, right? Uh, and also it shows you have um, about close to approximately 11,000 rows with 501 columns and such. Now, once you have this, you can add it to the data set. So the data set comes in, and then now you can add other similar data sets if you wanted to. You have, let's say, DS2, load it there, and you can check, yes, that looks like that, and then you add it to the data set. Okay. So you collect all the similar data sets right here. Um, now, let me go here and then take an example of one of this. So here is a data set that we have collected. It has a configuration file, where it came from, and then you can look at when it was loaded, what is the number of statistics, number of columns, rows, what is the start date, and what is the end date for that file, and where is it located as well. The advantage of this is you can use the tool, or you can use the actual command line tools, or even programmers can use Python to directly access that file. It's all in the same location. Now, once if you have this data, you know the time, right? And then if you want to check and explore this data, all you need to do is just go and double click it, and then you can actually plot, this is the way how that looks like that, and this looks like that. These two are correlated, and within few speed speed is the key. Within few milliseconds or seconds, you should be able to trend the data, and you say, okay, this looks good, and they are very similar as well. And you can explore all the data. Once if you are satisfied with the data, um, you can go do additional add-ons if you wanted to. You can plot the data on the separate system of as many rows as you wanted to. You can do single charts or multiple charts, and then within few seconds you can be having an intelligent conversation about your data. Right? That's the whole purpose of this. Next thing is, more often than not, you want to know what does this data looks like, so you can get the statistics for the entire data set. As you can see, within few seconds, you can take the data set. These are all the columns from the data. This is how the data patterns looks like. Like, rather than plotting each one of them, you can get a big picture of, oh look, these two look similar. What does this mean? These two, for example, 150 and 151, they look similar. Or 49, 50 and 51 look similar. So, or did anything happen here? If you are familiar with the data set, after a while, you can have quick conversations right away just by looking at the data. Not only that, it gives you first order moments of this data like mean, median, statistics, percentiles, number of unique values, how many things are missing, what kind of a data it is it correlated with time, is there a mutual correlation between the data sets? For example, if I were to go here, um, I'm sure, uh, see these things here. This is correlated highly with 107 is highly correlated with 1237. So you can see that there is a high level of correlation between those two data sets. That means there is some information captured um, in a duplicated way, so to say. So here you can see that these three rows are very exactly similar. So now once if you have the statistics, you have within few milliseconds or within a few seconds, as you can see, given the data, you have understood a lot more about the data than you can do with any other tools. Now, if you would like to understand these sensors, for example, what does this mean? You can go create a dictionary of that and then give it a description. For example, here in the statistics, if you hover over, it'll tell you, hey, this is a sensor, this is the meaning of it. So mostly you will have thousands of sensors, you won't know exactly what that sensor mean. So you can create a description and have it display wherever you are in this whole application. Next thing is events is something that, and also in the dictionary, as you can see, there is a coordinates. I will talk about the coordinates pretty soon. Um, Events is something that you want to think about. How do you capture events in your application, right? For example, there are different anomalies or splits that occurred, or maybe there is a particular event that caused the stocks to go differently. So those are all unique events that if you capture when those events happen next time, you can come back and say this event happened again. So you can have bit more information of the system dynamics, or you can say, hey, here is a new event, but by the way, this is innocuous. Don't worry about it. So for medical purposes, let's say that if somebody would be having a high blood pressure when they're driving or making a turn, um, your application might say, hey, you're having a heart attack, but then you can take a look at it and say that he's perhaps in a situation where heart rate is a meaningful thing to do. So it's not a bad thing, right? So those are all the intelligent things that you can capture in the system. Next thing is 3D modeling is about if you are modeling this in a human purposes or for the health analytics, you can put 3D models. I have loaded an example of a Orion capsule. This I got it from NASA. So here is a capsule, and remember that all those um, dictionary, all these sensors, they relate to a particular XYZ location. That is something that you can map those sensors here, and then you can intelligently talk about which part of the capsule that particular sensor is measuring, right? So that's also a very important thing, and most times people talk about the data set just like that, and without having the context of how it's used, where it's being measured, um, it's not so easy to understand the context of the data and how it can be applicable. So that's in essence most of the data exploration facility. Next thing we will talk about building AI models, right? AI models means if you have a sequence data, you can apply various different kinds of algorithms. These are all the data sets that you have. And now we just created test two, but now you can right away take this data and apply any of the existing models that you have. And by the way, if you have a new model that comes up, you can insert it here and then apply it and have non-data scientists do the job or do data science as well. For example, let me just work through, not go through the entire thing. I want to do analysis on this data set using a, let's say, a link model. These are the parameters I would like to do. Or if you have already built, you can go back and refine the model. and then you create, that will start loading the system and building the model. So we will talk about that in our next video, um, about creating a model, exploring it, creating the analysis, looking at the anomalies, and creating a dashboard as well. Thank you.